Hi guys, in today's video we're going to make it so that Marlo can run left and right. We'll add a nice skid state and animation kind of built in there, as well as give him variable speed by pressing our action modifier. And lastly, we'll even address some issues with slopes and how you can kind of overcome those in your game.
Hey, Michael here. Throw on your favorite game dev tunes and join me as we build a 2D platformer in Godot 4 using GD script.
All right, so let's go ahead and review where we left off last time. We built this player state machine and we've got these placeholder states, right? And when we run our game, let's go ahead and see what happens here. Then all we really have is Marlo just falling, and we can't control him, we can't move him. And so let's go ahead and begin today by making the run state, which is going to allow us to move the player, obviously, when he's on the ground, make him run around. Okay, and we'll even get into some advanced behavior, making him run faster when we hold a modifier key and so on. Okay, so go ahead and open your player scene. And then what we're going to do is come to our run state and open the script. And as you recall, we created these placeholder scripts with just a simple print statement when they enter or exit the state. Now the run state itself is going to have to handle movement and play new animation, but it's going to have a couple variables that we're going to want to export so that we have the ability to control the different speeds that Marlo can run. So let's go ahead and begin by setting up some variables. So I'm going to do export custom. And what export custom does is it allows us to just give it a custom property hint. And so we're going to go ahead and just set that up. And you don't have to do, you could just do a regular export if you wanted to, but I thought this was a fun way to introduce this. So I'm going to go ahead and inside of this export custom, it's going to want 2 arguments. So we've got different kinds of property hints that we can tell that we want. And really, we don't need anything special here. So there's one called none. I'm just going to grab none. Obviously, you saw a bunch of things, a string, float, whatever. Okay. And then what we can do is add a comma, and then we can add a string for the suffix by saying suffix. Oops, needs an X, colon, and then just typing what we want it to be. So I want it to be pixels per second like that, px/s. Okay, now this is, of course, is a variable. We'll call it speed. And we want our speed variable to be a float, a floating point number. And we'll just set it equal to 100 by default. And I'm going to go ahead and copy that. And I'm going to paste it. And this next speed is going to be called the sprint speed. Just like that. So we've got 2 speeds. How fast is he normal? And then how about when he's sprinting, right? So I'm going to go ahead and set this to maybe 150. Now we'll export a few other variables. What we're going to want an acceleration value, and this will allow you to control how quickly he gets to his speed, and when he changes directions, you know, how quickly he can change. We'll also have a skid acceleration speed, so when he's changing from like right to left running, we'll have a slightly different acceleration. And we're going to want to be able to provide an audio file for that skid effect that we'll do as well. And these values are handy because if you don't like the acceleration, you could just set it to 0 if you're following along with the code, or something very small. I found that even though I don't love acceleration in games, in fact, in this example that we're going to build with Marlo, he's going to be a little bit more skid and accelerate-y than I personally prefer in most of my games. But I've never really felt that it was 100% appropriate to have no acceleration, just personally. Even in other games I've built, even if I don't want much, I just add a tiny bit of a speed buildup, even if it only takes a split second, just because it feels slightly better to me. So anyways, this will allow you to kind of fine tune how that feels, right? So we're just going to do export for these ones. We don't have to do, you could do a custom like we've done, but really the standard way of exporting these variables, right, is just fine. So we'll just call this one acceleration. We'll also be a float, and we'll set this equal to 4. And then what did I mention next? Skid acceleration. Am I spelling that right? Yeah, I think so. And I want the skid acceleration to be a little bit quicker. So if you're running, you know, if you're starting from a stop, it'll accelerate at a rate of like 4, whatever that ends up being. I don't think it's pixels per second exactly, but if you're switching directions, like you're already running one direction and you press the other direction, I want that acceleration to feel quicker. Okay, otherwise you'll slide a whole lot, but you can fine tune that. That's why we've got 2 separate variables for those. And then I'm going to export one more variable that we'll call skid audio. And this is a variable that will be of type audio stream. Audio stream is just the resource type that we use for referencing audio files in Godot. And we do want 3 other variables that we're going to add here. We want a current acceleration, and this will come into play as we begin coding out the feature, why we have that. This will be a float. We want a current direction, which will also be a float. And I'm going to set this one equal to 0. And then we have a target speed variable, which will also be a float. Okay, so we got a few things set up here. I'm going to go ahead and comment out the init function. We don't really need it for this state, but if for some reason there was something you needed to set up, you'd have it. And there we go. Now, before we can really make this state work, however, there's one thing that we don't really have. So let's review and look at our project settings. We did set up initially in this project some input map. So we've got, buttons for left, right, up, and down and things like that. Nowhere in our code are we listening to and looking for that. And we could handle the input for those here in this script if we wanted to. But that's going to pose a couple issues. One of them being, how do we know that we need to get into this state if we're not already listening to those directions? And so obviously it's like, well, we could listen to those in idle. But also we're going to have some shared functionality amongst states that we want this to reside on. So if I look at the player state, for example, if you recall, we created this static variable called direction here in our player state class. So all of our states have this. And essentially what we want to do is set this direction in such a way that every state, if they want access to the direction the player's pressing, they can get it. Okay. So we'll go ahead and we'll do that before we can finish, or before we can really get into making our run state. Okay, so where I want to handle that in this instance, in the case of this game, is here in our player state machine. So I'm going to open this state machine script because we have access to all of our states here, and it really doesn't matter which state we update with this, because as you recall, our direction variable is static. So if we update the direction on one state, then all states will have access to that new direction that we've added. So here in our state machine, I'm going to come up to the physics process, or maybe just the process. Yeah, we'll do it in the process function. That's fine. So real quick, before we do our code to change state here, I want to update our direction based on the player's input. And this is going to be really simple code. So we're just going to say, we'll just grab our current state dot direction, and we'll just set it equal to a new vector 2, okay? And what we're going to do is we're going to dynamically grab some values from our inputs to be able to do this. So I'm going to hit return so that we've got a new line, and I'm going to use a function here for we've got two things, right? We've got the X and the Y coordinates, and I'm going to split these two up on different lines so that I can write out a little bit of code and it's easy to understand and follow, right? So it's not getting really long and hard to read. So the Y is actually straightforward. And so what we're going to do is we're just going to go input.getAxis. Okay. And then we have to tell it we want to get an axis based on which two inputs. And so what we want is we want up and then we want down. Okay. Because that's our X and Y. And we're only really going to use the Y coordinate of our input to determine if we should try ducking. I mean, that's pretty much it, but you could use it for other things like climbing a ladder or things like that. Now for the X, we could just do input.getAxis. And then we would do left and right. And we are going to use this actually, but let's go ahead. So let's go ahead and add this. And that's going to give us a value based off of our left and right direction. Let's go ahead and look at this input.getAxis function. It gets an axis by specifying two actions, one negative and one positive. And so if we look back at the code we've written, left is negative, right is positive, which makes sense because in our 2D world, anything that moves left moves in a negative value. So for example, if we take our sprite and I drag this over here to the left of the origin, which is center, and look at the transform, you can see that the X coordinate is negative 39. If I move it to the right, it's positive 30. If I move it up, what you would expect is that up might be positive, but it's not, it's negative on the Y. You see that? And then if we move down, it's positive. So let me just get Marlo back in the center there. We don't actually want to move that sprite, that's just for demonstration purposes. Okay, so that's why up is our negative direction and down is our positive direction, okay? And so then when you've bound your keys, if you're pushing left and up, then you're going to get like an up left kind of direction based off of this. But if you're just pushing left or right, you'll get -1 or +1, something like that. Now, one other thing I want to do with these though is that I don't want to just get left or right, because if you're using something with a thumbstick, you could get numbers that aren't a full value. Now, and I guess what I mean by full value is if a button is pressed, it's 1, and if it's not, it's 0, right? Like if the right direction is pressed, then we should expect the value to be 1 on the x-axis, and this should be -1. And this step that I'm going to do right here is very specific to the type of game we're making. I want my left and right to be on and off, but if you want the ability for the player to walk very slowly, then you might not want to do this. So this is completely optional what we're going to do right now, and you can try it with or without. But I'm going to go ahead and just add a little line to this code here on 22. I'm going to say sign and put in a parenthesis, and I'm just going to wrap this little statement where I'm getting the x-axis input. And what sign is going to do is it's going to basically make so that my value is either -1, 1, or 0. So you can see here we've got -6 returns -1, 6 returns 1. And this is important if you want to restrict to just like, am I pushing left or not? And you want a full value, okay? But if you want, if you're on a controller and you've got a thumbstick and you know how you can just nudge it a little bit, if you want to be able to walk slow, this is going to override that, right? Because if you get if you push it halfway, it's 0.5, well, you're still going to get a 1 with the way I've written the code. So again, optional thing that we're doing right here. And in fact, I'm going to go ahead and just copy this and paste it and put it on my up and down as well. So now what we've done is we've allowed us to get some direction here, right? By adding it to our current state. And we don't really have a way to maybe interface with that just yet. So let's go ahead and open our idle state script, and let's just do this something here in process, and let's just spam our console for just a minute, and let's just print the direction so that it'll print down here to our console, and we'll be able to see if that's changing or not. So let's run the game, and I'm going to make my game viewport a little bit smaller, and you can see it's spamming already with zeros. And if I push left, you can see it's now -1 and 0. If I push right, it's 1 and 0. And same with the up and down, it changes the y coordinate. Okay, so now we're getting some direction passed into our states. So that's a good test to verify that that's working as intended. We don't really want to be printing to the console every process frame. That's going to cause a performance hit in our game for one thing. But anyways, go ahead and remove that. And now we're ready to move on. Now that we're in our idle state currently, we do need to program and build a way into our idle state for it to leave this state and enter the run state. Okay, so let's go ahead and add that real quick. If we look at our process or our physics process, either of these would be an all right place to do this detection. And so what I'm going to do, I'm going to go ahead and just do it in the process function, I guess. And I'm going to say if direction, right? Because now we're updating this direction. If direction.x does not equal 0, meaning we're pushing left or right, then I want to return the run state. All right. And there we go. Now we've built a way for us to enter the run state, right? Because returning the run state is going to enter that. And I just want to remind us where we've been. The reason I can simply type return run is because in our base player state, we did grab a reference to all these different states. Okay. Otherwise, you couldn't just type run. You got to make sure that this is in your player state script in order to be able to type this line into your idle state. Okay. So if this is going to work, then we should be able to hit a direction and see our state enter and leave the run state. So let's go ahead and test that real quick. And yeah, you can see down at the bottom there, it says run, idle, fall. And then if well, I can't leave the run state yet, but you can see we went from the idle state, right? Exited idle and entered run state. Okay, so that's working. I'm going to go ahead and just clean up this exited idle state because I think that's going to be pretty obvious. Same with the exited run state. We'll just leave the entered on so we can see that. Now that we can enter our run state, let's go ahead and start working on it. And I want to do a couple things here. We're going to do some things a little bit out of order, but one thing we'll do though is set up in our enter we'll play the run animation on our player. So we'll just say player.animationPlayer.play, and we want to play, it's called run, right? We had an animation we called run. So now anytime we enter the state, he should change to that animation. And I'm going to do most of the coding here in the physics process instead of the process, but it shouldn't make too huge of a difference. There's a couple things we want to do. First, though, let's start with being able to return to our idle state. So we'll just say if direction equals 0, not direction, but direction.x, right? The x coordinate on our direction. Then we want to return the idle state. Okay. Now, just by adding this here and the run animation here, we should be able to see Marlo play run animation and stop when we leave. Okay, so I'm pressing a direction, then he stops. All right. So that's nice. We've got our animation hooked up, nice and simple. Now we want to be able to actually make him move. And the simple thing that we could do is just set the player's velocity based on the direction and the speed, right? We've got a direction that we're pressing, and we have a speed variable built in, right? Which is up here. So let's go ahead and do a basic version of that and just see how that works. Okay, so let's go down to our physics process, and kind of at the end of this function, we're going to just have a line of code where we set our velocity. We'll say player.velocity equals, and in this case, we have a direction, and we need the x value of that direction, and we need to multiply that by our speed. Our velocity, we need to set the x, right? Because our velocity is a vector too. We'll just set the x. Okay, there we go. So now we should be able to, if we play our game, I can hit left and right and he'll move. And of course, he's not stopping when we enter idle, which is not exactly what we want, but he's starting to move left or right. And there's going to be something else here. He's not going to, well, he's falling all right. Whee! Okay. But this isn't ideal. And there's a couple things, like we're going to have to go back to our idle state now because we never really did much with our idle state. Idle should say, hey, we want to be stopped. We don't want to move. Since we're going to be setting this player velocity from multiple places, I kind of want to have a function to make that a little bit more clean and simple. And there's also this concept of increasing or decreasing the velocity over time. And so we're going to go ahead and build the acceleration in right now. So before we do this, though, I'm going to make a generic function on our, well, we need to open our player script, right? Because this player script is the character body 2D. So if I'm going to have a common way to manipulate the velocity of this character body, the player, then I think this script is the best place to do that. So let's just make a function and func, and let's call it update velocity. And this update velocity function is going to need two values that we pass in. It's going to need the velocity that we want to update to, velocity, which is going to be a float. And we also want an acceleration value. So I'm just going to call it acceleration, which will also be a float. And then the function is going to be one simple line of code. And we can just say velocity.x. Man, I cannot type velocity for the life of me. Okay, velocity.x. We're just going to set this. Now we could simply set it to the velocity that we pass in by saying underscore velocity, like that. And in fact, let's go ahead and save this and go to our run, and let's say player dot, and then let's see, what do we call it? Update velocity. Okay, and we just need to pass in our velocity here, which we can calculate in the same way, right? We're going to say direction dot x times, and I'm just going to put speed for now. But we also need the acceleration. So let me just put, we have a current acceleration value. Let me not use that one because we're not setting that. Let's just use acceleration. We have an acceleration value that's, yeah, we'll use that one right now. Okay. Okay, so we're going to pass in our direction and our acceleration. And now if I save this and run the game, it's going to look just like it looked before. Okay, no change. But now when we go back to our player here, we can update how this function works. And then when we set the velocity in this way from any other script in the future, it'll function the same way. And so what we're going to do is, instead of just simply setting it to the velocity, we're going to use a function. And let's go ahead and just put it right here and it's called move towards, or move toward, singular. Okay, and then here we have a float from and to, and the delta. What is the change? And so the from is going to naturally be our current velocity. And since we're dealing with only the x, we're going to say velocity.x. So we're going to take our current x and move it towards this. And delta means by how much. And in this case, we want the how much to be the acceleration. Okay? So just by doing that, this should look and feel a little bit different now. You see how he's going to slowly speed up? And that's kind of slidey and slow, but you get the idea, right? Okay, and when I start from a stop, it actually looks okay. I can't, but obviously he's not stopping. So let's go ahead and make it so that he'll stop by coming over to our idle state. And we'll come down to our physics process. We already have this little code in here to see if we need to fall, which is fine. Before this, I'm going to add a little bit of code, and we'll just do player.update velocity, and we'll do 0. And we don't have an acceleration value here on our idle. And so let's do this. We could just plug something in, like let's just put 8 in here and run the game so that we can see if it's working. So when I go to the idle, you can see he stops. And I think that 8 value is pretty good, so he doesn't slide very far. And you're probably wanting him to look left when we move left. We'll do that. But so let's make this dynamic though. So if you want to change it, you can, and we'll just make a variable that we'll call deceleration, I guess. Deceleration. I think that's how you spell it. So we'll come up here into our player state and we'll say export variable deceleration, which will be a float, and we'll set it equal to 8. Okay, so now we can change that. And so what's fun here is let's go ahead and just play around with this for a minute. Now that we've set these export variables on our states, we've got deceleration of 8 on our idle. If we look at our run state, we've got a speed. We can increase the speed to 200, for example, and we could make the acceleration really slow, like 20. And then if I run the game, we're going to get something, well, 20, what did I say, slow? 20 is really fast, but you can see that speed's a lot quicker than what we had before. Okay, let's make this acceleration something like 2. And you can see it takes him a while to build up speed now. Okay, so you can play around with these values all you want and just find something that feels good. I'm going to reset them. The values that I put in will feel somewhat comfortable, and then you can tweak them a little bit from there. Now, I want to point out one other thing. Right now, when we run the game, this will be a quick, easy addition. When we're running, and we're still in our running state here while we're falling, you can tell because his legs are moving in the running state, and we don't play the fall animation. And I'd like him to do the fall state because my fall state is going to be distinct from the run state and things like that. So I'm going to go ahead and in my physics process here in the run state script, I'm going to just add, in fact, let's go look at idle. We have this little bit of code here. If player not is on the floor, then return fall. I'm going to just copy that. And I'm going to come over here to my run state, and I'm just going to paste this in the very top, just like that. Okay. So now if we run off an edge, he should enter the fall state. Yep, there we go. Nice. And we'll work on the fall state more in the next video, but right now, at least he enters the fall state. Okay. So pretty easy to change states, right? And then that way it limits our code to only doing stuff we want it to do when we're in the current state. Let's actually get back into running this. There's a few things we want to do. You know, in my code, we added an acceleration as well as, what did we call the other one? Skid acceleration. So when he's skidding, meaning he's like turning directions. Okay. We want to hook those up because right now we're only using our acceleration value. We also don't really support multiple speeds, even though we kind of indicated that we want to with these values, and we don't have a skid audio. There's just a few things in here, right? We're going to have to tackle these one at a time, but let's look at the acceleration in particular right now. When we change directions, it's accelerating really slow, and that feels floaty and not so good. That feels fine from a standstill, right? Like that. But when we're doing this, we don't want them to slow down like that. We're going to come into our run state here, and in our enter function, I'm going to go ahead and clear this out now that we know it's working good. We're going to start using these values here. We have current acceleration, variable that we set up because we have two types of acceleration. And so we just need to know, what we're going to do in our code is we're going to start referencing this, and then we'll set the current acceleration based on the type that we need. We'll end up doing the same with like target speed and things like that. Okay, so what we'll do is in our enter function, we'll say current acceleration equals acceleration. Okay, and we'll actually do the same for target speed right now, even though we're not going to use this quite yet. We're going to just set this equal to the speed. Okay, that's the default that we're going to want. Now, by doing that, we haven't really changed much. We do need to come down, though, to this line of code where we update our velocity. And instead of using acceleration, we're going to switch this over to the current acceleration. Okay, so now we need a way to figure out if we need to change the acceleration value. And what we'll do is here where we have this if direction x equals 0, we're going to add on to this condition. We'll add an else if here, or an elif, right? And what we're going to say is, let's get the sign of the direction, the x value, right? Because we're just looking at left and right. And we'll say if this direction is equal to, and this sign actually is going to be important even if you didn't use, especially if you didn't use the sign in the code we did earlier where we set the direction. We want to check to see, like, are we pushing the same direction that we're already moving? Like, if we're moving right, are we pushing right or are we pushing left, right? So real quick, let's just plug this next piece in. So we'll say player.velocity.x, because that's going to be our actual current velocity of the player. So if these are both +1, then we know that we're pushing the same direction, right? Or if they're both -1. In addition, we can also say player.velocity.x equals 0. In either of these circumstances, either we started from a standstill or we're pushing the same direction that we were already going, then we want to use our standard acceleration. So we'll say current acceleration equals acceleration. Okay, and then we can say else. And in this case, we want, meaning it's not, right? Which, like if we were pushing right and now we're pushing left, or if the player was moving right, now we're pushing left or something like that, then what we want our current acceleration to equal is going to be our skid acceleration. Okay, just this alone should actually add a different feel to this. So if I change direction, you see how he changed direction much more quickly now, because we have our acceleration value for the skid acceleration at 8. It's twice the value. Okay, so there we go. Just that simple change will give us a different acceleration. Now that we've done that, this is where I wanted to get a little bit tricky, because I want him to play a different animation. If you recall, let's look at our player. We actually did set up an animation called skid, where he looks like this. And we even have a sound effect that I would like to play. So if we come in here to our run, we've got this skid audio. Let's go ahead and set that. So let's work on this skid. On the run, you're going to have this skid audio. I'm just going to search for it. Oh, there it is. I only have a couple audio files. So we've got this skid, and it sounds like this. Okay, kind of goofy. A little bit of a skidding audio effect. And what we want to do is, while we're changing direction, we want to play that animation and play this audio. And for the most part, this is going to be pretty easy. We could put the skid audio as part of this animation. I don't really like that approach for this because I want to be able to stop it. That's a really long version of a skid, and we might only be skidding for a fraction of a second. So you might only get like a blow up instead of that whole long thing. So what we're going to do here in our run script, let's go back down to this statement here. We've kind of successfully determined if this is the case, if this branch of logic is true, that means we are running. Okay, now if we hit this else condition, that means that we are skidding. Okay, and so what we can do is we can actually just change the animation in here. So we could say player.animationPlayer.play, and then obviously this one will play run like we normally do. And if we're already playing the run animation, then that's just not going to change it. Here we could say player.animationPlayer.play, and then we would play that skid animation, just like so. I'm going to go ahead and save this, and let's hit F5. Okay, there we go. While we're skidding, he's got that little boop alternate animation. And depending on how long we're in that skidding state, it'll last. shorter or longer, okay? We also want to play the audio file when we're skidding. There's probably a lot of ways we could hook this up, but what I want to do is I want to just add a little bit of code into this state so I can tell when we start skidding, let's play it, and when we stop, let's stop playing it. And this code doesn't really tell us when we've started or stopped. It only tells us if we are or aren't. And we could build in some logic to determine that. But because we're using the animation player and we're changing it, we can actually hook into this animation player. It's got some signals that it emits when it changes animations, and we're going to just leverage that. It'll make our job easier. And so what we'll do is we'll make a function down here, and we'll call it underscore on animation changed, just like that. And when the animation changes, we're going to hook into a signal that actually gives us the animation name. So we'll say anim underscore name. It's of type string, like so. And that is a capital S, okay? This signal is going to emit, and we're going to pick it up, and we're going to take the animation name that it gives us, and we'll just basically ask the question, are we skidding or not? So if underscore anim name equals skid, then what we will do is we're going to grab our player and we're going to play an audio file, right? And we aren't quite set up to be able to do that just yet. Else, if we're not in the skid animation, then we're going to stop audio, okay? Now, of course, we can't do that just yet. Like I mentioned, we don't really have access to our audio player the way we want to. Or maybe we do, but let's look at it. So here in our player, like in our player scene, we do have this audio stream player 2D. We'll use this to play the audio. And I'm going to go ahead and increase the max polyphony on this. If you look at this, the maximum number of sounds the node can play. So I'm just going to increase this to something like 4. But if we look at our script in our player, we have a reference to the audio stream player. So I guess we could hook in and just play the audio, right? From the run state, we could say player.audio stream player 2D. But playing an audio file is going to require a line or two of code. And that's not a lot, but let's make another reusable function, right? Because we're trying to play audio on the player, maybe we want the ability to be able to control that a little bit better from the player's perspective. So just like we did with this update velocity, let's make a function on our player that will be called play audio. And in here, we're going to pass in an audio file, which is of type audio stream. It does not return a value. And what is this going to do? We'll just do a quick check in case we call this without an audio file. We'll just say if audio equals null, then we'll return. Okay, if we failed to pass in a valid audio file. Otherwise, we'll grab our audio stream player 2D. We'll set the stream by saying .stream equals, and then assign the audio file that we've passed. And then we'll simply say play. So we'll just call the audio stream player 2D again and say play. So now we've got this nice little play audio function. If we go over to our run state, here we can say player play audio, and we'll just pass in our skid audio like that. Now down here to stop the audio, I'm going to go ahead and we don't need a special function for stopping the audio. We'll just say player.audio stream player 2D.stop. This one is nice because we'll have other times where we want to set a new audio file and then play it, right? So instead of having 2 lines of code to do that everywhere, we'll just do it here with that one. And there we go. So now if we run our game, we should, we're not going to, because we created this function, but we never hooked it up. So let's come up here to our enter. Anytime we enter this state, we want to connect to that animation signal that I talked about. So we're going to say player.animationPlayer. And then the name of the signal is current animation changed. That's the one that we're going to use anyways. There's a lot of different signals, or a few different signals we could use. So we'll say current animation changed .connect. And we haven't really been working with signals in this series, but what this means is, the animation changed is going to emit from time to time. Whenever the animation player changes, it emits this signal. And we're just saying, let's connect to that. And anytime it emits, what are we going to call? We're going to call on, and no, it's not Ghostbusters. I know you're excited for that. But on animation changed. Okay. And there we go. Boom. It'll just call this anytime that animation changes. And what's cool is if we look at this current animation changed signal, you can see that it emits the name and it is emitted when the current animation changes. So let's run our game, and now it should work. Nice. Except I'm seeing that we're getting an error down here below. So let's take a peek and see what it is. Current animation change is already connected. That's great. I'm glad I didn't just do this and remember that we needed to. Sometimes it's better to see the bugs. So we're connecting to this signal every time we enter the state, but you can only connect once in a script to any given signal. So let's go ahead and I'm going to copy this, come down to exit, and we'll just disconnect. So it's almost the exact same. We're going to say, okay, player.animation, player.current animation change dot disconnect, and we still do need to provide the name of the function that we're disconnecting. All right, so that should clear up that error. Okay, pretty cool. Let's deal with one thing that's probably driving you nuts. It's bothering me, and it's that our player does not yet change direction, so he only faces left or right, okay? And again, for this, updating the direction that the player's facing is something that might happen from other states, and it's something that is primarily in the domain of the player script, in my opinion. So let's make yet another function on our player script, and we'll call this one update direction. How about that? Now, what the update direction is going to do is we'll just pass in a direction, dir for short, and it'll be a float. And it's going to be pretty simple. All we're going to do is we're going to take our player here. Let's put him on. The skid animation is almost confusing which way he's facing, right? Let's put him on idle. If we look at our sprite, there's this very simple feature that we can use when we're doing games with sprites. And that's, if we look at our offset, there's a flip horizontal. There we go. We can just flip him to change his direction, right? So what we're going to do here in our script and in this update direction, we'll just check if this dir direction value that we pass in is negative, then we'll flip him. If not, we'll unflip him. Okay. So we'll say if dir is less than, not dir. If it's less than 0, then we'll say sprite 2D, because we already have access to that, dot flip h equals true. And then we'll put an else statement, and we'll just do the opposite. We'll say sprite 2D dot flip h. Dude, flip the h out, man. False. Why am I getting an error here? Let's see, what does it say? dir. Oh gosh, did I spell it dire up here as well? I must have Dota on the brain. Okay, so now that we've got this function in here, let me copy it. And let's go over to our run state, and we'll call this in here. And we'll just do this again as part of our physics process function. I'm going to do this separate from that set of conditions. We'll just say if our direction, and we're going to check again just the x value, because that's all we need to flip it, does not equal current direction. Then we will call player dot boink update direction, and we'll pass in the current direction. Now, we haven't really used current direction yet, and so we're going to have to do a little bit more before this will work, right? So we defined our current direction. We don't set it anywhere. We don't do anything with it. It's just a way for us to easily compare. And so by default, we set our current direction to 0. Okay, but once we start running, this is going to change. So because what we'll do is if they don't equal, if our direction is different than our current direction, then we'll just set it. Our current direction equals direction.x. Okay, just like that. So by doing this, we'll just keep track, and we'll only change the direction when we've actually pushed a new direction. This should flip the sprite. Let's see if it works. Nice. And that sprite will stay flipped even when we enter other states. Okay. Voila. Now we change directions. We have one last thing to hook up and then maybe a little bit of cleanup, but that's making it so that we can run. We've got, or not run, but sprint, right? Run faster. Okay, so we've got this sprint speed set up, and we're not really doing anything with it. Let's revisit our project settings again. Hopefully when you set this up with me, you also set up a button that we can use for this. I called it action. So action is just, in this case, it's just a modifier. And you can see I bound it to a couple keys. So we'll hook into that. And we're going to do this in a couple spots. First off, if we're holding that key when we enter the run state, then we know we want the faster speed. Okay, so right here, we're setting our target speed equal to speed. We can just put a condition in here, if, and we'll just say input.is action pressed, meaning are we holding down, and we'll use the action. Maybe we need a different name for action than action. But so if this is the case, then we'll set different target speed, right? We'll say target speed equals sprint speed, just like that. And in order to make this blatantly obvious, let's go to our run and let's make our sprint speed like 400. So it'll be a lot faster. Okay, so now if we run the game with just that one change, if I move, you can see I'm running at 100 and I'm holding shift as I'm running. It's not doing anything. But if I stop, we got to fix that too. That's a bug. And I hold shift. Oh no, I don't know if it's working. I don't think that worked. I wonder why that didn't work, actually. Let's take a look. Am I setting my speed anywhere else? Let me just do a search for speed in here. Control F, speed. Oh, look at that. We're updating our velocity based on our speed. We got to change that to our current speed, right? There we go. That should make a difference. No, not current speed. Target speed. Okay, let's try it. Holding shift does nothing, but if I stop and hold shift, woo, he's going fast. Okay, there, that worked. Okay, one problem solved. Now we should obviously be able to toggle the run and not only start sprinting by holding shift, but if we let go of shift while running, then he should maybe go back down to the normal run speed, right? Okay, so let's go ahead and do that. And this is going to be pretty straightforward, actually. This is where we'll use, though, our handle input. So if we look in here in our little methods, you've got this little method finder. I'm going to click handle input, and we'll do this. If input dot is action just pressed, meaning was it just pressed this frame, not is it being held down, but did they just press it? And if they just pressed the action key, right, then what we can do is we can change our speed. So we'll say target speed equals sprint speed. We'll do an elif if input, let's see, dot is, and in this case, we don't want to do when they just press it, but if they just released that key, so is action just released, and we can use the same input, right? The action. Oh gosh, I'm starting to regret my decision to call that action. Then we'll set our target speed just equal to the regular speed. Okay. Just like so. So by doing that, we're now hooking into our button presses. So if I'm running and then I hold down shift, then he starts running fast, right? And if I let go, then he slows back down. So that works pretty good. And I'm going to go ahead and reset this to 150. I think that's 400 is a little bit fast to test that with, but you can see he's kind of faster, now a little bit slower. A little bit faster, a little bit slower, a little bit faster, a little slower. I don't know, that's actually almost imperceptible, but you get the point. Okay, so there we go. We now have the ability to run. We have the ability to turn and make our player face different directions. We've got a nice skid. Let's address this one little bug we saw, though. We've got if we're skidding, let's see. Let me go fast. It only will happen when we're going fast. If I let go of all the keys and I enter the idle state, that skid animation just keeps playing. That's pretty annoying. What we can do is just go to our run, and here in our exit, we can just call the same player.string, whatever, this stop the audio. So let's go up to our exit function. Boom, right there. So that'll stop it. So now if I can make this happen again. There we go. It stopped. I think this is pretty fully functional, but there's one last little thing I want to do, and this is just kind of icing on the cake maybe, but let's make our run speed animation play at a dynamic speed based on our player movement speed, okay? Now this might sound complicated to do, to make the animation player play at a different speed based on the movement speed of your character, but actually, it's going to be pretty straightforward. And let's go ahead and demonstrate this by slowing our speed down and increasing the max speed to like 300. I'm going to put the acceleration pretty high right now as well. Actually, I don't know. I think it's good with low because then we can see it transition. So I'm going to make it lower actually. Now what we can do is our animation player actually has an ability to change the speed scale. Okay. So let's go down in here to our physics process. And when we're running, when we're in this little branch of the code where we're running, not skidding, we're going to set our animation player's speed scale. And that's really simple actually. So we'll just say player.animationPlayer.speed scale equals, and we can just set it to a value. Okay. So for example, I could set it to 5. And if we run, it's going to go really fast. Okay. But what we want, obviously, is to make it based on our current speed. So what we have to do is make some assumptions, and you can tweak this a little bit. But first thing we want to do is we want to get our actual velocity of our player, not the direction we're pressing, but the actual velocity. So that's going to be our player.velocity.x. And because this could be a negative number and we don't want the animation to play backwards, we want to get the absolute value. So ABS, and then wrap that in some parentheses like that. Okay, so that's going to give us a positive number always. Then what we can do is we can divide this by the speed. And I'm going to go ahead and just run this. And you can see that actually looks okay. If I hold shift and we get our faster speed, you see how his legs are moving faster now? And then if I slow down, you know, it's actually working pretty good. So I'm just going to go ahead and stop that. Let's reset these values here to our normal values and run the game again. One little thing that we failed to do earlier that's actually kind of important and critical is because we've, down here in our physics process, because we've adjusted, where am I looking for? This speed scale, potentially. We want to make sure we reset that to 1 whenever we're leaving this state, so that when we go to the next state, hopefully it plays properly. So just here in our exit, we're going to say, so we'll just take this speed scale line. I'm going to go ahead and copy that first piece. And up here in our exit function for the state, we'll just paste this and set it equal to 1. That way our other animations will play at normal scale. And if we wanted them to play at a different scale, then we would handle that in their own state. All right. And you can see that he is indeed just slightly changing his speed. Even when he changes directions or starts, he kind of slowly starts taking a step, right? So there we go. We've now added kind of a dynamic animation speed to our game. You see how we're hitting this edge? And I can't quite run up that slope. It's too steep. Now there's some settings on our player, on this character body, that we can adjust to affect how he interacts with the world, and specifically with those different steep kind of collision sources. If we look at our player, we've got settings for the floor here. And you can see that we've got stop on slope, which is good. That's going to prevent him, if we go back here, if we go back to our game, he's not going to slide down this slope, really. Okay. We've got constant speed. I'm not going to mess with this one, but there's this block on wall. If true, the body will be able to move on the floor only. This avoids to be able to walk on walls. Let's go ahead and turn that off. And let's see what happens. Oh, it's almost working, huh? The problem is he's still kind of falling down. Okay, if we could jump, we could demonstrate that a little bit better. You see this max angle? I'm going to increase this. That slope is pretty steep. Let's say that our max angle is 66. And we might need to increase our snap length. This is like how far below him it checks. Let's just see if this works though. Oh, there we go. I'm now running up. Okay. And you can see if I turn, and he is kind of falling, we'll deal with that too. We have this constant speed. I'm going to turn that on. Now he'll move a little bit faster up that slope. Okay. But there's some settings here now that you can play around with. I'm going to go ahead and increase this snap length just to be safe to something like 2 and go back. That feels pretty good. And, you know, the last thing that we might want to deal with is him sliding down this hill. Okay, but I think we'll do that when we get to the jump and the fall states next. But there we go. We've kind of really fleshed out this controller so that he can move and do some stuff. And I hope this is helping you understand the why we might have a state machine if that's a new concept to you. And I hope you're learning just in general. So thanks for following along. Go ahead and drop a comment below if you have any questions or any other ideas on how this could even be improved. And as always, we'll see you next time.